Hello friends, today we'll learn about the diabetes data prediction, and today I'll use the support vector machine, and based on support vector machine I'll use support vector classifier, and subsequently I will do the training, testing, all those things. Okay, so let's start it. So first I am giving the name of today's lesson, diabetes prediction. So make it heading. Diabetes prediction. Okay, so first I will import all the libraries. So I will use import numpy as np, import pandas as pd, nppd. These are basically allies. Okay, you can use the other name as well. From sklearn dot model selection, import train test split from sklearn, import svm, that means support vector machine, from sklearn, import matrix. From matrix we will take the accuracy score in the last of our project. That means we'll calculate the accuracy of our design model. Okay, so that will be the last case that I will discuss later. So let's run. It will take some time. In the meantime, I am uploading the data set. So I am giving the dataset name as diabetes. Then I am using pandas library pd. Then I am using read.csv because the data file which I am going to import, that is in CSV format. Then I will put the path where I have kept the data file. So I am putting that path where I have kept the data file. So I'm giving that name. Okay, so let it be done. It will take some time to complete. Okay, so we are getting error. So let's check. Okay, we have to put .csv, that means file format. We have to put that thing also. So now it's completed. So let's check the diabetes dataset. Let's run. So this is the diabetes dataset. In that diabetes dataset, that means which I imported, there is 768 rows and 9 columns. Different columns like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, outcome, etc. This is the outcome. In outcome section, you are getting 1 or 0. So let's take how much 1 and how much 0 is there. So I will use diabetes. Then I will put the column name, that means here in this case outcome. Then I will use dot value counts. That means I'm going to find out how many values are there for each and every segment. So let's run it. So it is showing that value counts. Okay, it will be yes. Okay, now let's run it. Okay, you are getting 0 for 500 values and you are getting 1 for 268 values. That means 0 these type of rows are there. There are 500 rows of these type of rows, and these type of rows are 268 rows. So I'm just writing it here that 0 basically denoting that non-diabetes, and 1 basically denoting then that person has diabetes. So now what I'll do, so I will going to segregate my entire data set into two parts. That means X and Y. That means I'm taking some portion of the data set as input and I'm taking the remaining portion as output. So it is quite obvious that outcome will be the output and the remaining 8 columns will be taken as input. So I am doing X, that means X variable I am taken as input. So I will use X. So let me just copy it here. In that case, I don't need to type it again. So diabetes, then I will use drop, then I will put the first bracket, and here I will use axis equal to 1. So what I am doing here, that means I am going to drop the outcome, this particular column from diabetes dataset. And since I am going to remove column, that's why I am going to put axis equal to 1. If you put axis equal to 0, in that case, you are going to remove the rows. So let's run it. Okay, so let's check the value of X. You are getting 8 columns and that outcome columns had been removed. Okay, so in the Y section, you are getting the outcome column. So just copy it and paste it. So in that case, I need to copy, no need to type it again. So I'll just remove that portion, that means drop portion. So let's run it. Now let's check the Y. Okay, you are getting 1010 something. Okay, that means in Y you are segregating, you are separating your data set into X and Y. In Y section, you took the column value, that means the outcome column value. Okay, now if you observe very carefully, you will get that in case of X data set, okay, there are different type of values are there. Like in pregnancy, you are getting 6, 1, 8 something. That means this range of value. If you observe in diabetes pedigree function, you are getting 0.627, 0.351, like in this type of ranges of value. In case of BMI, you are getting 33.6, 26.6, 23.3 in this type of range value. That means ranges are not similar everywhere. Okay, so you have to standardize this range. Okay, so otherwise you will get some error in your designed model. Okay, so now I am going to standardize my data set. What is the logic behind to standardize this data set? Because the data, what are contents in this data set, those are in different ranges. Some in, you know, the 30, 35 ranges, some in fractional ranges, some in single digit ranges, something like that. Okay, that's why we are going to standardize our data set. The behind or the logic behind this standardization is that we are going to set all the values in some range. That means you can say 0 to 1. Okay, we are going to convert this type of situation. So to do that thing, first we need to import some library. Okay, so I am using from sklearn dot processing, pre-processing sklearn.preprocessing import standard scalar. So let it be run. Okay, now I am doing one instance, let's say scalar. I am doing these instance on standard scalar function. Okay, so I'm creating scalar instance of standard scalar function. So let's run it. Okay, now, so first add some rows first. Okay, so now what I'll do, I will do scalar. First I will the standardize. I'm just denoting it standardize. Then I will do scalar, that means that instance dot fit, that means we are going to fit the x value, then transform. Why transform? That means we are going to transform our data set, that means what are in different ranges. We are going to transform those different ranges value, different ranges data set to a particular ranges. So here I am putting the x. So let's run it. Okay, so now let's check the value of standardize. I'm just putting it here. Now run it. Okay, you are getting 0.63, 0.63, 1.4, and if you observe carefully, you will see all the values in this range. It is not like that something is 36, something is 140. It is not like that. Something is 1, something is fractional. It's not like that. Everything is in same range or same region. Okay, now I'm doing x equal to, that means I am just assigning the standardized value to the x variable. So let's run it. Now let's print the x. You are getting the same value. What was there, that is also here. Okay, so now I'm once again the displaying the value of y as well. So it is the y. What was earlier as well? We didn't change anything on value of y. Okay, so up to this, we have segregated our data set into two parts, the input variable and output variable. That means input variable is x and output variable is y. Okay, so now what we do, what about the data we are taking for input purpose and what are the data we are taking for output purpose, we'll segregate those data into two parts. That means the training and testing. Okay, so what I'm writing xtrain, xtest, ytrain, ytest equal to train, test, split. This we already got from sklearn dot model selection. So now x comma y comma test size. Here I am putting test size 0.2. That means I am taking 80% data for training purpose and remaining 20% data for testing purpose. You can do it 70-30 ratio, you can do it 90-10 ratio as well. Okay, as per your choice. Now I am doing comma stratify. I'm telling why I am using stratify. I'll tell you. First, let me write stratify is stratify. Stratify equal to y. Then I'm putting random state equal to 2. It will be comma, it will not dot. Okay, first I'm telling you about the random state. Okay, random state equal to 2, it is the way in which process your data will be reproduced. If you put random state equal to 3, you will get a different value what I will get. Okay, if you put random state equal to 2, only that case you will get that answer what I will get. Okay, so it is basically how your entire data will be splitted, how the data will be reproduced. Okay, now I'm telling you about the stratify equal to y. If you observe the value of y carefully, you will get 1 0 1 0 1 0 0 1, something like that. Okay, if we don't use stratify equal to y, stratify equal to y means you are going to stratify the value of y variable. That's why I'm writing y. Now I'm telling you the logic behind stratify. It may be possible that all the 1 may goes to under x y train, all the 0 may goes to under all the 0 may goes to under x test. So such type of situation may come. So to remove this type of situation, so this type of situation is not good for the perfect model designing. So to remove this type of constant or to remove this type of situation, so that the 1 or 0, both the values distributed, uniformly distributed. Okay, that's why we are using stratify equal to y. Okay, so let's run it. Okay, now you have segregated input variable and output variable. After that, you have segregated the input variable into two parts, that means training and testing, as well as the output variable into two parts, that means training and testing. Okay, now you will use the support vector machine. First, I am using one instance. I am giving the name instance model. Then I am taking svm dot svc, that means I am using the support vector classifier. Then I am using kernel. Then I'm doing linear. So let it be done. Okay. Now what I'll do, model dot fit, that means I'm going to fit the training value in the model. I will use x train and y train. So let's run it. Okay, that means your model has been fitted with the training value. Now what I'll do, I will check the accuracy for the training data set, as well as I will check the accuracy for testing data set. Why I will check the accuracy for both the purpose? Because I will check that any kind of overfitting or underfitting issue should not come in our designed model. To justify, or to rather I can say to check that thing, I will take the accuracy score for both the cases. That means based on the training data set as well as based on the testing data set. So I am using x train predict. That means I will going to determine the x train prediction value, but I know what is the actual value will be. Actual value is y train, but I want to predict the value. I know actual value is y train, but I want to predict what it will be. So I will use model dot predict. Then I will use the x train. So let's run it. Now I will use accuracy score based on training. Matrix, what we have imported from sklearn, matrix dot accuracy score. Then I will use that measured value, that means this was the measured value, x train predict. Then I will put the actual value. Actual value is y train. So let's run it. Now let's print it. Accuracy score based on training. Let's print it. It should be a okay. So your accuracy score based on training is 0.7866. That means 78.66%. Okay. Now I am doing same thing, but now I will do based on testing data set. So let me just copy it. So I no need to write it again. Just I will change it this train to test. Here also I will change this train to test. So let's run it. Now again I will copy this line and I will paste it here. Again I will change training to testing, and I will also change it here as well, and also y train I will change to y test. Now let's run it. Now check the what's the accuracy score based on testing. So your accuracy score based on testing is 0.7727, that means 77.27%. Your accuracy score, so let it be right. Okay, accuracy score, so just copy it and paste it here, equal to 78.66%, and accuracy score based on testing is 77.27%. So make it bold. Okay, so your accuracy score based on training is 78.66%, and accuracy score based on testing is 77.27%. So there is, we can say, almost same. There is no such big deviation, there is no such big difference. Okay, almost similar, almost same. So we can say there is no such overfitting or underfitting issue in our designed model, and our design model is perfect. Okay, and if any machine learning project your accuracy score is greater than 75%, then we can say that this designed model, this proposed model is good if accuracy score is greater than 75%. So this was all about for today's lecture. Today I have shown you how to use the support vector machine, how to use the support vector classifier. If you get the data set on different ranges, on that data set your values are in different ranges, something in fractional, something in 100 ranges, something is in 1 2 3 such ranges. So how can you standardize your data set? That part also I have shown in this video. So thank you. This was all about for today's lecture.